When the Daniel Senior orifice fitting became available over 60 years ago and allowed orifice plate changing without interrupting line flow, it fostered a significant change in pipeline operating procedures. The design emphasis provided an orifice valve with the major operating parts which could be replaced or repaired in the field without removing the fitting from the line. It is extremely important that repair of a Daniel fitting be done properly to maintain the safety and quality that is so important in the Daniel design. Specifically, this means following a proven repair procedure and using only Daniel factory-made replacement parts. This latter point cannot be stressed enough, as the use of unauthorized parts will void the Daniel factory warranty on the fitting. The program you're about to see and hear assumes a familiarity with operation of the Daniel Senior orifice fitting and specific safety procedures for the company where the work is being done. We will examine how to repair problems with bleed-off, shaft operation, lubrication, and plate carrier alignment. Let's first look at how to correct bleed-off problems. When the fitting will not bleed off for plate removal, even though correct lubrication and operating instructions have been followed, it will be necessary to take the unit apart. Follow the prescribed safety procedures. Depressure the meter tube and orifice fitting. Remove the clamping bar and sealing bar. Then remove the plate carrier and inspect it carefully for worn or chipped teeth. Next, remove the equalizer valve for inspection. Remove the upper plate carrier shaft. This will be easier to remove with the top in place unless a vise is available. Before going further, it is important to understand the various kinds of stuffing box assemblies. Early senior fittings were hand-fitted, and this means that hand fitting is required when putting new stuffing boxes in the fitting. If the senior has the latest type stuffing box, no hand fitting should be required. Here are cutaways of the various types of stuffing boxes. The important thing to remember is that the new stuffing box must end up exactly the same overall length as the box it replaces. Loosen and remove the hex nuts holding the top. Hammer wrenches are usually required to break hex nuts loose, and a chisel may be needed to split badly rusted hex nuts. Leave 1 or 2 loose nuts on until the top is actually being removed. This is important when the fitting is rolled 90 degrees on its side. If the top is frozen to the bottom section, use thin wedges to work around until the two parts can be separated. When the top is loose enough, remove the remaining hex nuts and slowly pull off the top. If the fitting is rolled to the side, watch for any internal parts that may fall out. Set the top down with the valve seat side up. Clean and inspect all parts for damage, wear, and chipped teeth. Examine the valve seat and valve strip very closely. Usually, improper sealing is caused by dry, hard lubricant in the seat grease channel or by burrs or cuts. Remove the valve seat. Then, clean off all the old gasket material. If the seat is to be reused, remove the stop pins. Inspect and clean the equalizer valve opening. If the ball seat appears deeply rounded or cut, use seat dressing and reseating tools to correct the problem. Place the valve seat gasket on the top with the holes correctly aligned. Then install the valve seat. Lightly snug all seat screws working from the center outwards. Tighten each using the same sequence. Go back over all the screws to ensure tightness. If the seat is to be lapped, do it now before installing the valve carrier stop pins. Use a flat block with fine emery cloth to lap the entire length of the seat with even pressure strokes to remove all cuts and scratches. Clean the seat with penetrating oil. Then install the valve carrier stop pins. Inspect the grease gun and replace it with a new one if necessary. Next, purge the grease port. Then, rub fresh slide valve lubricant into the grease channel. Next, check the alignment of the slide valve. Place the valve strip on the valve seat as it would normally be in the open position. Push it into the lubricant on the seat. Place the valve carrier over the valve strip and push both against the stop pins. Now remove the valve carrier without disturbing the valve strip. Run a sharp knife edge along the edge of the valve strip nearest the stop pins. Move the valve strip back towards the open position and note the mark made in the lubricant on the seat. This will indicate whether or not the slide valve is aligned over the grease channel in the closed position. Adjustments can be made by slightly bending the stop pins or by marking and filing the valve carrier at points where it hits the stop pins. This fitting has been rolled to a side position. Install the valve carrier with the guides on each end in the bottom section of the orifice fitting after making sure it is parallel with the shafts. Move it to the fully open position. Then roll the plate carrier to the bottom. Don't use force. If necessary, file, cut off, or grind the upstream side of the valve carrier until the plate carrier passes smoothly without rubbing. It should pass clear of the valve carrier edge. After placing the plate carrier in the bottom, hold the valve carrier and rotate the valve carrier shaft towards the closed position. The valve carrier should pass over the plate carrier without hitting it. If it doesn't, file, cut, or grind the valve carrier bottom until it clears without rubbing the plate carrier. Move the valve carrier to the open position and remove the plate carrier. Move the valve carrier towards the closed position until the downstream edge is halfway over the plate slot. Push several sticks of slide valve lubricant against the guides and ends of the valve carrier to hold it in place. Make sure the valve carrier will remain in this position. Use more lubricant if it won't. Put slide valve lubricant in the spring holes. Then install the springs. Smear slide valve lubricant on the valve seat. Then push the valve strip into the lubricant against the valve seat. Position the valve strip with one edge slightly less than halfway over the seat opening, making sure that its ends and back edge are evenly spaced. Install the top shaft assembly. It can be tightened after the top is installed. Then install a new equalizer valve, or if reusing the old one, packing should probably be replaced. Apply to the threads some type of thread compound compatible with the products that are being measured. Install the top over the bottom studs just enough to start hex nuts on each corner. Do not wiggle or push the top any further at this point. Begin pulling the top down against the bottom while maintaining an even gap. Check frequently through the top opening to make sure parts are lined up correctly. Note, however, that on some fittings, hex nuts under the top bearing plug and stuffing box should be started. When the top is pulled down with such a fitting, there will not be clearance for installing the hex nuts. Continue pulling down until the top is against the bottom section. Wiggle the shaft that operates the slide valve to help parts align properly and pieces fall into place. Then operate the slide valve assembly to make sure it will open and close. If anything binds and does not assemble properly, stop and find out what is causing the problem. Roll the plate carrier into the orifice fitting to see if it works smoothly. If not, slightly loosen the hex nuts just enough for the top to move. Then roll the plate carrier until it is engaged between both the upper and lower plate carrier shaft pinions. Now, snug down the hex nuts and check the plate carrier operation again. Install and snug down the remaining hex nuts, tightening them evenly from the center outwards. Make sure the upper plate carrier stuffing box is tightened with the packing nut installed to prevent damaging the threads. Replace the sealing bar using a new gasket. Then replace the clamping bar. Tighten the clamping bar screws from the center outwards to ensure a good gasket seal. Pressure up and check operation of the fitting. Now that we've gone over the disassembly and reassembly process, Let's look at how to correct shafts that are difficult to turn. Normally, shafts become hard to operate because of oxidation between the stuffing box gland and shaft. To correct the problem, depressurize the fitting if this has not already been done. Remove the packing nuts. Then, work the glands until they are free. Usually, spraying with penetrating oil, holding a gland with vice grips, and turning the shaft with the operating wrench will free a gland. If the gland doesn't loosen, back out the stuffing box several turns, making sure the plate carrier is away from the shaft being worked so the carrier won't get cocked to one side. Strike the shaft end squarely with a hammer until it seats in the bearing plug. Retighten the stuffing box. And spray under the gland with penetrating oil. Place the outside end of a packing nut against the gland and tap the edge with a hammer. Then remove the packing nut and work the gland until it is loose. Some type of lubricant compatible with products handled by the fitting should be applied under and around the gland. Replace the packing nut and tighten until the shaft turns slightly stiffly. If you see leaks after the fitting is again pressurized, tighten the packing nuts only to the point that stops leaks. Do not over-tighten. It may be necessary to dress shaft ends with a file if the ends have been peened while hammering. Another type of repair deals with lubrication. A Daniels Senior orifice fitting should be lubricated with the slide valve lubricant recommended for the service in which the fitting will be used. This lubrication not only provides a seal between the valve seat and valve strip, but also prevents lubricant from becoming dried and hard in the grease gun, inner ball check, and grease ports in the body casting. Dried, hard lubricant can block fresh lubricant from being injected by the grease gun. As a result, it is possible to rupture the inner grease ball check, or the grease gun body can be split from hydraulic pressure created by tightening the grease gun stem. To remove the inner grease ball check, bleed off all pressure in the meter run and orifice fitting. Next, remove the external grease gun. Then, clean out the opening. Next, use a square-ended tool to remove the ball check. Do not use an Allen or hex wrench. Clean and inspect the ball check after it is removed. It should be a Daniel-approved unit, and there should be 2 balls in its end. If you do not find 2 balls, the check is probably ruptured, and the balls are lodged at the end of the grease port. Spray a suitable solvent in the hole. Penetrating oil, WD-40, liquid wrench, and similar products are commonly used. Both balls must be removed before installing a new grease ball check. Use a long, thin pick or sharp-ended stiff wire to fish out both balls. If necessary, chase the threads using a 1/4 inch NPS thread tap. Clean the hole and install the grease ball check. Inspect the grease gun. Then replace it. Do not over-tighten the grease gun against the ball check because it could rupture, and the grease gun ball could lodge against the ball check, thus preventing grease flow. Lubricate the orifice fitting slide valve. If lubricant cannot be applied to the slide valve after replacing these parts, Remove the top and clean out the grease port. Never use lubricants with fibers or Teflon particles, as they build up around the balls inside the inner grease ball check and could cause rupture. Use the proper lubricant for your type service. Standard Type 1 lubricant should not be used for ethylene or H2S service. If there is any doubt about the proper lubricant, check with your Daniel representative. The last type of service we will discuss is when the plate carrier has been inserted unevenly and is cocked in the fitting so it won't roll out. Do not force anything. Trying to force movement will only make matters worse and may break pinion teeth or damage the valve seat. As before, depressure the meter run and fitting and remove the clamping bar and sealing bar. Visually inspect the internal parts. Remove the entire shaft assembly, including the bearing plug on the shaft which engages the plate carrier. If the pinion teeth are broken, the shaft must be replaced. Remove broken teeth from the plate carrier with a thin rod or piece of tubing flattened on one end. Hold the shaft so it is parallel to the plate carrier and is evenly spaced on each side. Work it across the plate carrier until it engages the plate carrier teeth evenly and is centered in the stuffing box and bearing plug holes. Work the shaft back and forth easily to help put the plate carrier in place evenly. Install the bearing plug and stuffing box. Then roll the plate carrier out. Check the other plate carrier shaft for broken pinion teeth and replace if necessary. If the plate seal keeps the plate from rolling out of the bottom chamber, spray some type of lubricant around the seal while applying reasonable force to the lower plate carrier shaft. It is fairly easy to break pinion teeth in this effort, so a replacement shaft should be available. If this method fails, remove the fitting top. Then drill and tap the plate carrier for an eye bolt and use some type of pulling device. Do not chip or cut around the plate seal. This will damage sealing surfaces and cause leakage around the plate seal when the orifice fitting is put back in service. Verify whether or not the straightening vanes are still in place. Loose vanes can lodge against the plate and prevent its removal. It is important to emphasize that using the recommended lubricant and following proper operating procedures will minimize the need for any of the repairs outlined here. You will save time, cut the costs of repair, and eliminate the associated frustration. If you have problems other than those just discussed and are not sure how to handle them, please check with a Daniel representative. Daniel is as anxious as you are to make sure your senior fitting is kept in top-notch operating condition.